Hello. Today we are going to be talking about Polygon Modeling 101, or Modeling 101 in general. What is modeling? In computer graphics, 3D modeling is the process of developing representations of 3D surfaces and objects with specialized software. The product is called a 3D model. Models can be created automatically or manually by an artist. The manual process is comparable to sculpting in the real world. Let's learn some terms. Polygon and polygon count. 3D models and assets are composed of polygons. The poly count of an asset refers to the number of polygons an object is made of. Higher poly counts equal more detail but longer render times. Vertices, edges, and faces. Polygons are formed from points in space, which are vertices, and the lines, which are edges, and planes, which are called faces, that connect them. Primitives. The simplest geometric objects from which most geometric models are derived from. Some 3D modeling packages include more complex primitives such as the Utah teapot or Suzanne, Blender's monkey mascot. NURBS. NURBS stands for Non-Uniform Rational Basis Spline. It's a mathematical model for generating and representing curves and surfaces, and an alternative to polygonal modeling. While polygonal modeling is usually faster and more intuitive, NURBS are far superior at representing curved surfaces and are less render intensive. Soft and hard modeling refers to modeling soft organic objects versus hard architectural objects. Each type of modeling requires different skills and aesthetics. Box and subdivision modeling. Start with a geometric primitive like a cube, a sphere, a cylinder, and refine it by extruding edges, adding tessellations, and moving vertices and edges around. Edge or contour modeling is building the model piece by piece by placing loops of polygonal faces along prominent contours of the object, then connecting them together. This is sometimes called patch modeling. This technique involves refining planar surfaces rather than volumes. NURBS or spline modeling. This is when you model the object using NURBS curves instead of a polygonal mesh. Used heavily for automotive, industrial modeling, and DreamWorks animation for a time. NURBS modeling is a great way to start a complex model, and you can later convert it to polygons. Popular sculpting programs are Maya, 3ds Max, Blender, Modo, and also Cinema 4D. Digital sculpting. You can create the mesh organically and mold and shape the model like a sculptor would clay using texture brushes and other tools. This is done with popular programs like ZBrush, Mudbox, and a subdivision of ZBrush called Sculptress. Sculpting takes an entirely different skill set than polygonal or NURBS modeling. Often an artist will have to take time to convert sculpted geometry back into polygon meshes for animation purposes, but skilled sculptors can make better models faster than conventional polygon modeling. Procedural modeling. This is a way that you can generate the models algorithmically, so through the computer, with a computer program rather than manually by an artist. It's used for complex, numerous, or otherwise overly time-consuming modeling projects. Popular procedural programs are Houdini, City Engine, 3ds Max, Chrome, and Bryce. One of the main advantages to procedural modeling is that it is non-destructive. That means its node-based system allows for changes, revisions, and additions to be made quickly. Artists can explore new ideas without losing previous work and create systems for generating sets of assets rather than individual objects, one by one. Solid modeling. Solids and BIM, or Building Information Modeling, are other forms of 3D modeling that focuses on physical fidelity. Whereas polygons are constructed of infinitely small points and infinitely thin faces, the purpose of solids are to inform design, assembly, or simulation, and therefore always have thickness and often are attributed with realistic material properties, such as tensile strength or energy efficiency. Creative approaches. 3D scanning. 3D scanning usually requires a lot of expensive and so specialized hardware and software, but the results can often be very good quality and take a fraction of the time. Image-based modeling. Model an environment or an object algorithmically from a set of 2D images. Used when manually modeling the objects would be too expensive or time-consuming. This is also called sometimes photogrammetry. All right, let's talk about something that matters. Let's model something. So, open Maya and you start modeling. This is a pie chart of time spent working on a 3D model and actually working on the model versus nonsensically spinning and moving around the model. So once you start modeling, here are some essentials. Extrusions. One of the primary tools for adding geometry to a mesh, extrusions extends faces or edges inward or outward. Here is how you can find the extrude tool in Maya. Maya 2018 and 2019 are a bit updated, but the mesh tools and edit mesh functions are basically where you could find extrude. You can also find it in the modeling toolkit. Subdivision and smooth. Subdivisions or subdividing adds resolution to a model either uniformly or selectively. A good rule of thumb when modeling is to work on broad strokes. Don't subdivide your model into more faces until it looks good at lower resolution and poly counts. Otherwise, it becomes unmanageable. Here's where you find the smooth function in Maya. Edge loops. Add subdivisions gradually with edge loops. An edge loop can be added across any sequential polygonal faces without adding resolution to the rest of the mesh. It's very handy. Edge loops can be found, once again, under Mesh Tools in Maya. Now in Maya 2018 and 19, instead of the polygons drop-down, it's found in the modeling drop-down. Bevels and chamfers. By default, objects in Maya have infinitely sharp edges, but in reality, almost every edge has some sort of taper or roundness to it. Use bevel or chamfer to take this into account. And here's where you could find the bevel or chamfer tools. By the way, you will be able to find this PowerPoint on eCampus. Modeling Essentials orthographic views. So most 3D modeling packages allow the user to view a model orthographically, or to see the character turnaround, to see the model from multiple angles at once. You can create concept art to capitalize on this fact so that modelers know exactly how an object should look. You can then import it into the program and use it as reference. An image plane is a planar image used for reference when modeling in a 3D software package. You load your orthographic concept art as image planes in order to make sure your model objects and characters are accurately modeled in 3D. All right. Tris and quads. No G-gons. You don't want those. You want good topology for your model and good edge flow. You need to use an economy of polygons and make sure to watch your density at articulation points. These all make good models. Let's talk more about topology. And no, not the type of topology in a map. This topology. Topology refers to the structure of your mesh and the way the mesh flows around the surface and details of your model. Good topology allows for clean deformations when animating, while bad topology can cause unnatural deformations and even textural or lighting artifacts when rendering. Topology is one of, if not the most important aspect of modeling. You should try to always model with quads. Triangles are okay. Never anything more than quads. It will deform horribly. You have to take into account good topology, because when you rig and you attach your model to the rig, that's when those deformations are really going to show. Here's some topology terminology. You heard me refer to quads. Quads are four-sided faces. They don't terminate loops, directional. They're your best friend. They're excellent. Tris are three-sided faces. They terminate edge loops. They can cause pinching and should generally be avoided. N-gons, 5+ sided faces. They're good for roughing out a model, but they must be removed before the model is final. In fact, there's a lot of programs that work in conjunction with Maya, 3ds Max, and ZBrush that help you texture and speed up your workflow that will not work if you have any tris or N-gons. They only work with quads. Poles. That's a vertex with 3 or 5 edges connected to it. Terminate edge loops, directs topology around details. 3 and 5 poles are sometimes unavoidable, but others, 6+, should be removed. So edge loops are continuous lines or edges on the surface of a model. Edge loops and how they relate to poles and different polygon types are everything in topology. So find the quads and poles here. All right, subdividing N-gons creates a huge problem. So this is what these two cubes look like previously. One is full of quads, the other is full of N-gons, it's full of poles. I don't see any tris, but it's a mess. And so when you smooth it out, the one on the left creates a big hot mess, and the one on the right is nice and clean. Soft organic topology. So edge loops should follow muscular shape contours. Quads are very important for maintaining directional flow and for allowing subdivisions to form properly. Hard surface topology. Edge loops should outline major details in order to maintain hard edges. Tris may be appropriate on flat surfaces but should otherwise be avoided. Low poly modeling. Though you should always strive for a quad-only mesh, triangles can be useful for details and hinges in low poly situations. Always use triangles sparingly. When you subdivide triangles, they can cause pinching. Edge loop planning. Draw the object you are planning to model and trace the topology across its surface. Plan out how you are planning to form it out of square polygons before you start the modeling process. This is when it helps to know more about life drawing and the anatomy of the subject you are trying to model. Here are examples of major topology lines. Recognizing bad topology. So on the left we have very bad, and on the right we have good. As you can see on the right, it's made up of all quads. On the left we have N-gons. We have all sorts of oddly spaced topology, and it's extra super dense. There's entirely too many polygons. Here we can see good topology versus bad topology. So for the topology on the left, you see that the edge flows go with the flow of the mouth and the musculature, where here on the right, the edge flow does not go with the musculature of an actual face. And so the way this face will deform will not look quite right once you start animating it. Whereas here, we're still flowing with how the underlying musculature flows. All right, so up here we have some very good topology. This is good topology, and this is very bad topology. And we saw an example, a close-up of this bad topology in the previous slide. Topology poles. Poles, vertices with more or fewer than 4 edges leading into them, are very important for directing the flow of topology. Some poles should be removed, while others are unavoidable or even desired in moderation. So here are examples of some of those poles. Pole types. E, 5 poles, also called an extrude pole. An E pole is created when you extrude a quad. When you extrude the mouth, eye, and ears of a character, you will get 4 E's each. You'll also get them when you extrude the arms and legs from the torso. And 3 poles, sometimes called a nose pole. 3 poles are created to give purposeful detail to specific parts of the topology, such as the nose. Deleting them is possible, but removing them also removes detail from the model, as you can see in the visual examples on the right. Use poles to control how edges flow across the mesh. And try and control your flow. Here is an example of a Blender lesson of controlling topology workflow, which you can watch at your leisure. You will have access to this PowerPoint presentation on eCampus. More examples of flow and more examples. Appropriate density. More dense mesh at articulation points and areas that will deform. So you want your mesh to be a little bit more dense at places like the knees. The more edge loops you have in an area, the more easier it will be to deform those faces believably. So knees and elbows are important places where you're going to want some denser topology for better articulation. Also, knuckles on the hands. What makes a good model? Well, ask these questions before modeling. What type of actions does the model need to perform? How close to the camera does the model get? How much screen time does the model get? These questions determine how much or little time and effort should be put into the model. Common pitfalls. Naming conventions. Naming conventions are very, very important. As you can see in the images here, we have a good example where everything is named properly on the rig, and then we have a very bad example where everything is cube, 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 sphere, 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 plane, 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 plane. How will you know what everything is and where it's supposed to go and what you're supposed to select if you don't name it? The easiest thing to do is to name things as you make them. Common pitfalls number 2, not freezing transformations or deleting history. When you don't delete history, you will get something like where the red X is, where you see all the inputs and you see all of the information under that. That is history. And what that can do is that can cause your computer to, well, the file to take on way too much data. So when objects are modeled, they create history nodes that track changes made to the model. Though this data can be useful in the modeling process if something goes wrong and you want to recover a previous version of the model. When objects are moved around in a scene, the translation, rotation, and scale transform data is tracked. These attributes are often manipulated when animating objects. However, when a file is referenced or imported into another file, it will bring with it any transformed data in history, which can be disastrous to deal with, especially for riggers. Always be sure when you are done modeling that you 1. Delete history and any empty groups or nodes left over in the outliner, 2. Move the object back to its origin, and 3. Freeze the transformation so that the values read as shown. Translate X, Y, and Z 0, rotate X, Y, and Z 0, and scale X, Y, and Z 1. This guarantees a clean, easy to find and manipulate model for artists working on later parts of the pipeline. Not freezing transformations and deleting history. That can cause all of the issues mentioned before. So here are how you would do that. You would go edit, delete by type history. If your character is rigged and you have skinned your model, then instead of deleting history regularly, you would go delete by type non-deformer history. Under the Modify button on the main menu, you will find the Freeze Transformations option. Common pitfalls. Not starting at the origin. So starting an object at the origin helps when determining the scale of your object, but also makes it easier when you are done and have to move the object back to the origin for other artists to find. Not toggling Smooth Mesh Preview on and off often. Pressing the number keys 1, 2, and 3 change the way the objects are rendered in the viewport. Many beginner modelers are attracted to the smooth mesh view, which simulates what the object would look like if subdivided and work exclusively in that view, making changes that might make sense in the smooth mesh view, but actually cause problems on the original mesh. Always be sure to work from the original mesh view, 1 on the keyboard, and check progress with the smooth mesh, 3 on the keyboard, to prevent problems. Subdividing too often too soon or too often. Subdivision is a powerful and seldom used tool that generates a lot of extra geometry very quickly. Subdividing too often can overwhelm a computer with superfluous polygons that slow down render times without adding any visible detail to the model. So subdividing too soon before a model looks good at a low resolution can create unnecessary work for the modeler, who now has more polygons to deal with than necessary. Subdivide intelligently and only when necessary. Here are resources and further reading. More resources and further reading.